Okay, it's 10 o'clock. Let's go ahead and get started. So I want to say first, welcome. This is going to be the first day of our summer preparation program. You've gotten a lot of communication about this so far already, hopefully. It's for incoming data science master's students, but others are welcome too. My goal is going to be to make this program really, really good and fun for everybody. I've been building towards that for several years. I've had this job since 2017 and have been working on what you see here since 2018. And I think it's really starting to come together, and I hope that you feel that way too. So as you've seen in other communications, the curriculum for this program is going to be the sequence of data gymnasia courses. So these courses are hosted on mathagon.org. That's probably what you've seen, but I've sent some emails more recently about the Prismia versions of these courses. And, as it says in the message, they're newer, and I think some of them are significantly better because I've put more work in the process of moving them over to Prismia and taking advantage of some of the flexibility I have in this platform. So hopefully you've gotten a chance to take a bit of a look at that. If not, then you'll have plenty of time to see it over the summer. So each of these mini courses, much like class itself, presents as a sequence of messages. And the idea is that you treat it as a conversation. So you can respond to any message as you go, just like a regular chat conversation. But certain questions will be marked as required to respond, and that's indicated by the registered symbol. There are also other required questions without that symbol, which is just a multiple choice. And you can tell because you get these orange suggestion chips that pop up. And the nice thing about the suggestion chips is it will respond automatically to what you say, whichever answer choice you click. There is also some preliminary work on doing this for open response too, but that's coming. That'll happen later in the summer. I will say it can be kind of annoying if you have to click through every message if what you're really trying to do is just get a high-level survey of what's going on. And so for that reason, we have a light gray show all button, very small text in the top right corner, and that just takes you all the way to the end. So then you can use the table of contents that's going to pop up when you do that to navigate back and forth. So the idea is to make it slightly onerous to look ahead and then come back, because that tends to be the difficulty with these systems. If you can kind of peek ahead and look at the answer and then come back and write your answer, it sort of short circuits the exercise for you. So there's some incentive to actually just answer things as you go in sort of a conversational style. But if you go too far, and if there's no way to roll back, that can be really frustrating. So the show all and then reset is what you want to do in that situation. So okay, this is great. I'm seeing more and more faces popping up on my Zoom panel. Looks like we've got 29 folks here. So I want to discuss a little bit more for reasons that will become apparent in a moment before bringing other people on screen. But I'd like to hear from some of you. So what I'm going to do first, though, is introduce this platform. So this is Prismia, and I'm sure that you haven't used it before. So we're going to need to talk a little bit about what's going on here. The goal is that the learning curve is going to be very minimal for you as the student, but still you need some orientation. So the idea, just like with the asynchronous stuff we just discussed, the idea is going to be that class is a two-way dialogue between the students and the instructional staff. So you're going to say things, I'm going to be able to see what you say. On my side, respond to you, share it with the class, all the kind of operations that you would expect to be able to do. And the dynamic here is that when you send a message, it appears in your chat thread, but they can be shared with other students. And if a message is shared with the whole class, it's going to appear in your screen on a light yellow background. So that's if someone else's message is shared. So let's try this. So everyone send me a message that says, hi, my name is, and then whatever your name is. So I'll share the first one that came in. So you see it pop up with the light sort of, I guess, orange really, more than yellow. But that's going to be a message from another student. And what you can do is hover over the icon here and see who that student is. So the idea is that you want to use this feature generously. You want to send plenty of messages as you go. It's okay if you send too many sometimes, they'll be ignored. But for the most part, they'll be incorporated in some way. Either I respond by adjusting the way that I'm pitching the content, or recognizing a common pattern in the questions that I'm getting, and answering that for everybody. And I can also answer some questions one-on-one when they're kind of create space in class for people to solve little exercises, and while everybody's working, I'll respond to some of you. Okay, and of course, feel free to ask questions. So I added a feature which I call the call on me setting. And the idea is that, like, I never really know, or before I didn't know. So I'll just show you where it is first. So there's this call on me preference. You can say call on me or don't call on me. And you can set that, and it will say how you choose it, and you can just switch it whenever you want. So the idea is that I don't want to cold call on someone. They share a message with me, and then I say, oh, I'd love to hear from Shabam. And then all of a sudden it turns out he can't speak because he's in an environment where there's background noise, or he doesn't want to disturb someone or whatever. So I'm trying to give you a way to communicate that to me, and that way it will be apparent who I can call on and who I can't. Yeah, so I showed you that feature. Sorry, I got a couple messages ahead of myself. So I would encourage you, if you are going to speak, you can just turn your camera on like while you speak, because it'll help us feel like we're getting to know one another better. But if you don't want to, that's fine as well. Okay, so one other point that is relevant to disclose is that I'm going to be recording these class sessions and making them publicly available. So the way this works is I upload them to YouTube, and I can embed a YouTube video on a Prismia shared lesson so people can go through the messages and watch the video at the same time. That's the concept. However, that doesn't work so well with students being in the room and speaking out, because then you have to wonder, do I want to be on YouTube or not? So what I'm going to do to solve that problem, I have to edit the videos anyway. So I'm just going to edit out any instance where someone else appears on camera or speaks. That way you can speak, and you don't have to worry about it ending up on the YouTube video. If you want to be in the video, and I'll make an exception for you, just tell me, hey, like, just leave me in, then I can do that. You can also change your profile image and your display name under profile, which is, again, in that top left drop down menu here. So update my profile right there. So I just want to give folks a chance to say some things, how you're feeling. Okay, so this is Yash. Do you want to take the screen, Yash, introduce yourself? Okay, cool. So I see one other one, which is Luke. Do you want to introduce yourself, Luke? Shui Ying, is that, you can correct my pronunciation. Do you want to? Nice to meet you, Shelly. Thanks for the introduction. Yeah, I can just share a few more of these now that they're coming in. Yeah, so I'm really hoping to do a great job with this. As I said, in the past, I think it has been, students have enjoyed the summer program, but it hasn't been thorough enough to really help people prepare. It's been sort of very slow paced and a bit sparse. So it's going to be much more intense this year, and you can just modulate that up or down by, leaning into it more and learning as much as you can, or just getting as much as you can from it based on reduced time commitment. All right, so a little bit more stuff about Prismia. The goal for the most part is going to be to do our programming in Prismia. So I can send you a message that has some code, and if I indicate the message as such, it will have this code cell that you can pop open and run. And so this is Python, as you can see from this little icon down here. It's the two snakes. And this is real Python, by the way. This is not running in your browser. The downside of that is it runs on a server, which is generously hosted by Binder, and it takes some time to start up. So basically, your browser is sending a request to Binder that says, hey, start me up a server with a Jupyter session going. Give me access to the kernel through my browser, and I'll send you code, and you send me stuff back. And it's kind of slow initially. You didn't see that because I started it up before class, but it takes often like 30 seconds for the first code cell, which is slightly annoying, but then it's totally fast after that. You saw an example a second ago. Sometimes, unfortunately, because again, it's a free service that's being hosted by Binder, and so you have to start over. And the only real way to do that right now is just to restart the browser. So bear that in mind. Sometimes your code cells will go sideways somehow. Just refresh the browser, it should fix it. Yeah, if you want to read more stuff about Prismia, go to the landing page. There's a slideshow at the bottom. link in the top left corner to a guide. You can read more. Hopefully, won't really be necessary though. I'm hoping things are intuitive enough. You just pick them up as you go. I want to go through the syllabus a bit. I'm going to do this fairly quickly because you have a chance to read this on your own. Probably already know if you have questions. I want to kind of get to that part quickly. So the kind of initial component of the workflow we'll have here is a pre-class reading. So the idea is you're going to work through the specified sections, the ones listed in the calendar on the landing page, and kind of have that content ready to solve more exercises for and learn more about in class. I think class works better for more people if it's like interesting exercises, extending some ideas, that kind of stuff, rather than trying to introduce everything from scratch, because it can be pretty slow if for people who know the content pretty well if we do it that way. So in general, in my classes with the pre-class reading, if you want to do it thoroughly, and again, it's a summer prep program, you're not getting academic credit for this, and I'm not giving you a grade. So, I'm certainly flexible about however people want to use this to best meet their learning needs. But in the version of this where you're sort of trying to do as much as possible, the pre-class reading is going to be a lot of work. So this is different from other courses where you have lectures, kind of a previews, kind of showing you where things are. Here we want to actually practice in class. Okay, so the second component is the live class meetings. That's what we're doing now. We've already talked about kind of the workflow for that. I'm also going to be creating some assignments, very modest, a lower workload than you would have in a typical course, partly because it's not a full-fledged course and because there's a lot of practice embedded in the pre-class reading and the actual class time. So I don't have an assignment up now, taking it easy at the beginning because I understand a lot of people are going to be joining in early June. But I did include a sort of assignment 0 that just, otherwise you can't get into the interface and see what it looks like to do an assignment. There's not actually anything there, it just says, hey, basically. So yeah, another component that I'm adding this year is small group meetings. So I've mentioned this in the communications, but the idea is that some people last year especially said, some program is great, but it really needed to be bigger. I needed more contact with the material, more, frequent opportunities to get together with people and learn stuff. And of course, doesn't really work just to have a lot more class meetings because then lots of people feel overwhelmed by it and don't feel like they can participate. I don't want to have one of these, every day of the week. So a good, I think, more flexible solution to that is to have you take on some of the work of organizing that. So I'm going to provide a framework to connect people into small groups so that you can, meet with those people regularly and manage amongst yourselves how you're going to work through the curriculum. So you'll be able to prepare content and share it with the other people in your group, and then you can rotate who's doing that. So obviously, that's not a thing that you'll see in a lot of courses. I think it would feel uncomfortable to do it in a real course because it's kind of you're offloading some of the instructional work onto the students. But in a free course, I feel totally comfortable with it. And I'm really curious to see how it goes. I'm hoping that what happens is that a lot of people take a lot of ownership of the process and do some really cool stuff, maybe contribute some content back that can be used in other groups or in future courses, that sort of thing. So it's very much part of the vision of Prismia. You build content in here, and then it can be used either as a step-by-step asynchronous lesson or as a live in-class lesson, and it's all freely shareable from one person to another. So kind of like slides are in that way, except more dynamic and editable. There are a lot of details on the homepage. I'm going to leave you to read that later. So last thing before we start with the actual content for today. So I'm just going to pause here for a minute or so, put a bit of timer on this message. To give people a chance to ask any specific questions about these logistics. Okay, so here's the first question to come in. Is the assignment part required? Required is it's not an entirely applicable concept to this course, I would say. I think if you want to get the fullest experience, you should do all the components. If you want to start dropping components one at a time, I'd say the first one to drop is either the small group or the assignments as you prefer, and then the pre-reading, and then then the live class, then the pre-reading. So the day gymnasia course is I'm asking everyone to do that, because what happens if people come in and a lot of folks have not really seen this content is that we have to spend a lot of time introducing certain just common notations and conventions that are used to kind of provide background for the course, and I want to get everybody on the same page. But anyway, yeah, that I would say it's required if you want to max out the kind of most you can get. But you can drop anything at all. You know, you have a vacation in the month of July, just drop out the entire month. You know, it's not like I'm gonna, bother you about it. Okay, so it seems like there aren't that many questions. So that's just as well. We can go ahead and get started on today's content. So we're probably not going to get through everything. That's fine. I'll when we don't get through with something, I'll just put the shared lesson up anyway, and that way people can go through it. Sometimes in the winter session, I taught 10 lectures on R this past January, basically December and January. And what I did then was some days I would just finish. I would just say like, okay, we're at the end of the hour, class is over, leave if you want. But then for the Zoom recording, I would just keep talking through the rest of the content, and that way the video is complete. So I might do some of that, or I might just leave some of it only covered in the actual shared lesson. Okay, so let's get started. So we're going to talk today about sets and functions. This is kind of it's the first Data Gymnasia course, and it provides some vocabulary that's applicable throughout all the other courses. So it's not super, deep on its own, the level that we'll be going into it, but it's just helpful to have some common terms nailed down. So hopefully you're familiar with sets and functions from prior courses that you've taken, but that's okay. We're going to talk about some facets that tend to go underrepresented in the ways that these things are usually talked about, and maybe make some interesting observations along the way. So I'm going to be assuming in principle that you've seen the sets and functions course. I know that in fact most of you haven't, so but I think it's fine because this content is pretty commonly covered to some extent in prerequisites for this program. So okay, so here's our first multiple choice question. Is the set 1, 2, 4 different from the set 4, 1, 2? So one of the things that I can do is summarize the message block and send that out to you. So in this case, the correct answer is no, it's not different. And most folks got that right. That's great. So I can send this class response summary showing what all the different things people said were. And one thing you can see here is that you can send a message that says something other than one of these two answer choices. And also, just want to point out, we have our Prismia bot here, this little orange bot. This is the one who pops up and answers or responds to the answers that you give for the multiple choice questions. So this isn't done in Data Gymnasia, but I'm going to here just go ahead and incorporate some computation so that you can see what this looks like on the programming side. So we can define a set in Python using the same syntax as in math, exactly the same. So curly braces and then listing the elements. And then we can check membership with the in operator. And so sure enough, 1 is in 1, 2, 4, whereas 5 is not. So the key point I want to make here about the correspondence between the sort of math side and the programming side is that they align in the following sense. So you can check membership for a set in Python, but you can't ask what's the first element. So in Python, bracket 0 says give me the first element of this, and that does not work. Python deliberately tells you you can't index into this set with a number, so that operation doesn't make sense. So this is the sort of Python side of the idea that order doesn't matter when it comes to sets. Okay, here's a little math question. I'm just kind of curious where people are on this. So when you see the Blackboard bold R, the set of real numbers, and the Blackboard bold Q, which is the set of rational numbers, what's the difference? Okay, so a couple of themes here. So let me summarize what folks are saying. Yeah, so various facets of this that people are highlighting. So here's someone who's taking some analysis. Q is dense in R. Q is a subset of R. They have different cardinality. That's fine. Yeah, okay. This is what I was going for right here. I mean, all this is right, but rational numbers are numbers of the form a over b, where a and b are both natural numbers, and real numbers include the entire number line. So that's more stuff that in between the rational, so to speak. Okay, so there are numbers like square root of 2 of pi or pi, which are not rational. They can't be written as a ratio of two integers. So they're different sets, but rationals are a subset of the reals. Okay, here's another multiple choice question for you. What is your opinion about the Blackboard bold N, or do you have one? You can also just say this is a popularity poll. I'll show you what everyone says, and we'll see which one comes out the winner. It's a close race. It's very close. We have a new leader. I don't want to give it away. All right, here we go. So the starting with 1, that definition was winning initially, and then the late folks came in strong for the 0. All right, but yeah, this is right. It's defined differently in different contexts. It usually won't matter whether 0 is included, but when I say it, if it does matter, you should assume I mean 1, 2, 3, and so on. So not including 0, but usually it either doesn't matter or it should be clarified. Okay, so next let's talk about set operations. So the union operation says what are all the elements that are in either of the two sets. And in Python, we can do this with the union method of a set. So we define two sets, S and T. We do S dot union of T, and that gives us all the elements that are in both. So, one of the challenges with working with any programming language is that you're looking at a blinking cursor on the screen. You don't unless you know the language really well, it's not like you have a bunch of menus to pull stuff up in. So you need a kind of way to replicate that to some extent within the language. And of course, you can look at the documentation, but that's not a universal solution. Depends on how good the documentation is in a given package. So here's a little hack for Python. You can call the __dict __ method on most anything, and it will give you some useful information about that thing. Like in this case, it's going to tell you about all these different methods you can use. So if you want to intersect two sets, for example, you can see that's probably going to be this one, intersection. So yes, let's just see what that looks like. We take the intersection of S and T. That's all the things that are in both S and T. So that's just the number 1. All these other numbers are different. So just one other operation, the difference operation. That's everything that's in the first set, but not the second set. So unlike the other two, this is not symmetric. If we do T difference S, we're going to get different stuff. Okay, so here's a small open response question. So suppose you want to email everyone who hasn't submitted a form yet. So you have an original list of email addresses that you sent the form request out to, and you also have the form submissions, which have email addresses listed. What set operation are you going to be using in order to follow up with the people who haven't responded yet? Yeah, so I'll just summarize what folks have said so far. I realized I forgot to put a timer on that one. But yeah, you're right. Everybody's on point here. So this is a set difference operation. I thought of this example very easily because I use this set difference operation all the time. I have utilities built so that I can grab lists of email addresses from anywhere and whip up a set difference. Okay, so those are pretty basic, easy to understand. Throw all the items in a bag, that's a union. Take all the items that are in both, that's the intersection. Another one that often does confuse folks, though, is the Cartesian product. So here's a message directly from the Data Gymnasia. So if we flip a coin and roll a die, so there are two things that are both happening, and we want to know what are all the ways that both of those things can happen. So we can have a head in any one of the 6 die outcomes, or a tail in any one of the 6 die outcomes. So there's 12 outcomes there. They fit nicely into a grid. So this is a Cartesian product. And when we talk about probability, we're going to talk about Cartesian products a lot, because this comes up all the time in any sort of experiment. You're going to be collecting multiple pieces of data, and you're not going to know from the outset, oh, it's impossible to have this particular combination of data. The universe of possible records or collections of data that you're going to collect from a given individual is going to be a Cartesian product. Like if you collect first name, last name, date of birth, height, and blood pressure reading, then you're going to have the space of strings crossed with the space of strings, crossed with the space of dates, and so on. This is going to be the set that your records are going to take values in. So here's an instance of it that comes up pretty often, and people are often. I'm going to put a clock on this one. I forgot to put a clock on several of these. So this comes up pretty often. And people are always like, "Wait, what is that?" Initially, and so I'll just give you a chance to get familiar with this notation first. So if we use 0, 1 with brackets to denote the unit interval, then what geometric object corresponds to the Cartesian product of that interval with itself? It's not really a well-posed math question yet. I suspect people are going to converge on the same answer anyway. All right, so as I suspected, people did decide they want to visualize this set in the same way, which is with the unit square. All right, so nice job. So this set is typically illustrated with a square. That is dependent on a choice of representing the ordered pairs x, y using the Cartesian coordinate system with a plane as a geometric representation. But given that very canonical choice, 0, 1 cross 0, 1 is the square because it's all the points whose x coordinate is between 0 and 1 and y coordinate is between 0 and 1. So the interactive graph was a little gratuitous here, but that's okay. You're going to see lots of instances later where it's genuinely really useful, especially in data 1010. Okay, so in Python and in linear algebra, we talk a lot about lists. So lists are in some ways in programming, they're more commonly used, often viewed as a more fundamental data type. In math, sets are usually taken as a fundamental data type. But in any case, the point of a set is that you can ask the question, what's the first element of this list? We can define L to be the list 1, 2, 4, and then say, hey, what's the first element of it? And it's 1. Great. You might have seen in your linear algebra course the term set being used instead of the term list. And this is a bit of an imprecision because you want to be able to say things in linear algebra, and we'll get to this content if you haven't learned it yet, but you want to be able to say things like I don't want to give it a name right now. Curly braces v comma v is linearly dependent. So that's an idea in linear algebra. And if you know linear algebra, it's going to be really clear to you that this is always the case. Yet, if you call it a set and you say this is a linearly independent set, you kind of messed up because it's equivalent to the set that only contains one instance of that vector. And if v is non-zero, then this is going to be linearly independent. So it's a little weird and not mathematically accurate to call collections of vectors in linear algebra sets if you want to be able to speak about them in the usual way. So that's why we introduced this term here mathematically. And then, as I said, it's also important in programming. Okay, so let's move on from lists and talk about functions. So I want you to sort of reflect on the various ways that the term function is used and what are kind of some of the differences of between the different manifestations of the idea of a function. So in math, a function is just an assignment which associates an element of one set to each element in another set. So if you have some data and you want to associate with each of those pieces of data some other piece of data coming from some other set or the same set, then that's a function. So it's a very abstract, flexible notion. So like a simple representation of function might be a table where you have your domain elements on the left and your codomain elements on the right. So this set A that f is mapping from is called the domain. The set B that it's mapping to is called the codomain. So here we're mapping apple to 3, bread to 1, squash to 3. That it should be super familiar. Also, when we talk about math, we sometimes with a bit of abuse talk about like really abstract and kind of ill-defined functions. Like you can say hypothetically, suppose there's a function that tells you for every sort of latitude longitude pair, for example, every point on the surface of the earth, it tells us which way the wind is blowing right there. And that's not a really precise thing, but we can still think about it, and we can think about what might be true of any particular model. And in fact, we often do that in math classes. So this is quite different. But both of these things are really quite different from what a function looks like in a programming language. So for example, in Python, you can have a function, let's call it square, which takes an input and returns its square. So this is like a mathematical function. It takes an input and returns an output. So it takes 3 and gives 9 out. So that makes sense. But we can also have totally different kinds of functions that don't return anything. So this function has no return statement, and it in fact returns nothing. So if we say print square of 3 and assign the result to y so that we can explicitly print it, Python is going to tell us there's nothing there, didn't return anything. But it had what's called a side effect. So it did some stuff along the way, namely it wrote out to to your screen here, and you'll have a lot of those situations in programming where you'll have a function. It's not actually designed to return a value to whoever called it. It's rather the caller telling the function to go off and do some other thing. So those are called side effects, and this function here has no side effects. That's called a pure function. Right, so math functions are like these pure functions, whereas this is something different. It is a bit confusing to call this a function because it's not a function in the function sense. Sorry, in the mathematical sense. It's only a function in the programming sense. So here's kind of an interesting point, or interesting until you first thought about it. Suppose that we want a function inside. We want to represent the mathematical function in a programming language, which maps, let's say, each person's student ID to their email address. Let's say for all the students in a particular class. What should we do? What kind of a structure inside of Python is going to store that data and allow us to interact with that data? All right, people are really converging on the same answer here. Yeah, so the folks who answered were on the ball with this one. You want to use a dictionary, not a function. So let's actually break that down a little bit, and I'm going to suggest one other alternative that no one suggested. So we don't want to write a function that just goes through if the input is this and return that, if the input is the other thing, return the next thing, and so on. This gets to be extremely onerous. It's also slow. You don't want to embed all of your data in your code. That's a mistake. So there are two good ways to do it. One is to use a dictionary. That's kind of the canonical answer, and folks said that. That's great. Another way that's sort of a bit more practical for this specific use case that has the same pros and cons really from a computational perspective is to pull in this data as a data frame and then use that data frame to perform these lookups. So it's going to work similarly under the hood to a dictionary, but it's going to print things in a pretty way and interact with comma-separated value files in a nice way. So this bit.ly link class email data just has some dummy student IDs and email addresses. What you want to do, and we won't really get into the details here, just kind of want to show you what this looks like. But what you want to do in pandas, which is a standard, definitely really kind of the only data frames package in Python. Huge amount of effort has gone into making this package really great and performant, and you definitely want to use it if you're doing data science in Python. But in any case, what you want to do in pandas, if you want to use a particular column as a lookup column to grab other data that's in the same row as a particular identifier, is you want to call set index on that data frame. So that's going to return a data frame that knows that you're going to be looking stuff up with that particular column. Once you've got that, you can perform that lookup with what's called the .loc accessor, which is just the way that pandas does this. If you want to put in a key that's one of the indices that you just set, then you need to call .loc on the data frame and then access that way. Anyway, the details there aren't that important. I just wanted to kind of plant it in your mind. Dictionaries are Python's built-in way of doing this, but when you're dealing with data that you're accessing from a database or from a static file, you probably want to use a data frame instead, because it's just going to provide more conveniences and a lot of the same computational benefits. By the way, this is what the data frame looks like once you've indexed it. So here it's indexed by 0 to 99, and then it has 2 columns. And here the index column is actually the student ID. So the original range index that's going from 0 to 99 is gone, and now this is what's telling us which row is which. So I have some more stuff here. So let's talk about codomain and range. So I mentioned this earlier. So the codomain of a function is just the set that the function's outputs are guaranteed to be in when the function is specified. So you cannot infer the codomain of a function from some rule that specifies how the function behaves on its inputs. It has to be given as a part of the function specification by whoever is defining the function in the first place. On the other hand, the range of the function is determined by the domain and the rule that is used to map each input to its corresponding output. And the reason is that the range is the subset of the codomain consisting of only the elements that actually get mapped to. So I'll just give you a single picture. That's really all you need to lock this idea down. Here's F, here's its domain and its codomain. It happens to map inputs only to these two values, so this is the range, whereas the codomain is this whole thing. So just a few pieces of terminology about specific constraints you might want to put on a given function. So in some instances, you don't want a function to have the behavior that this one does, where it maps two inputs to the same output. You want it to be the case that every input maps to a distinct output. Whereas you can leave one out potentially. You're not so worried about that if you're talking about injectivity. So what would be an example of a real world function which is injective? Okay, some people have read the, okay, that's a good one. It's another good one. I like these kinds of questions because it gives me some examples to kind of draw on later. Okay, cool. So lots of good ideas there. So the thing we just mentioned about student IDs is an example of an injective function. Okay, here's another word, surjective. So here, the point, it's sort of the complement, if you will, of injectivity. So in injectivity, we really don't want to be mapping two inputs to the same output, but we don't care if we miss outputs. Here we have the opposite concern. We don't want to be missing any outputs, but we don't care if we map two inputs to the same output. So that's surjective. Yeah, I have some more questions here. I'm just going to skip over them for the interest of pace. We'll get to some of the maybe a little bit more interesting questions later on. So bijectivity just combines these two. It says you don't map two inputs to the same output, and you don't leave anything out. So everything's one-to-one. And this is what you need to be able to do a function inverse. So if you want to be able to reverse all these arrows and still have a function, then you need both injectivity and surjectivity. Okay, so here's a little math question. So suppose that f and g are bijective functions such that the codomain of g equals the domain of f. So what is the inverse of f composed with g? So that's the function that says first plug into g, then whatever you get out, plug that into f. And by the way, you have a little equation editor. If you weren't looking at the screen, you can pop open your equation editor and do math quickly, faster than typing LaTeX if you're used to typing LaTeX. Also, you have Unicode completion. So if you want to type like alpha, you can do \alpha tab. If you want an integral symbol, \int tab. Shubham is pointing out that he doesn't have the equation editor button. I had to get that by customizing. Top left, customize equation editor. Okay, in any case, what's going on here is that if you visualize the composition of f and g with a potato and arrow diagram like this, you can see that g takes an input to its output, and then f takes that output to its output. If you want to reverse that process, you need to go in the reverse order. So first do f inverse and then do g inverse. So that means that the inverse of f composed with g is g inverse composed with f inverse. It flips around. So we're going to see that quite a bit when we talk about linear algebra. That's why I wanted to preview that now. Okay, so I just want to put up these few messages about elementary functions. We'll talk about this more when we talk about calculus. But so the exponential function, which is denoted e to the x, it's the function of the form a to the x, where the graph has a tangent line of slope 1 at the origin. So if you plot 2 to the x, which is what's shown here, the slope at the origin is this number 0.69, whatever. You need to increase a little bit to get it up to the point where the slope is right around 1. And you'll see that if I get a to be 2.71, that's pretty close to e, and indeed the slope is around 1. Then once you've got the graph of the exponential function kind of locked in, you can come up with the graph of the log function in your head by just reflecting it over the line y equals x, because log is defined to be the inverse of the exponential function. So log of a number really close to 0 is a big negative number, log of 1 is 0, and then log grows slowly as you move to the right. So by the way, you can move around in these interactive graphics. You just need to hold the shift button down if you're on desktop. You can hold the shift button down and move around. And yeah, I think we're pretty much out of time here. So yeah, I'll just leave it at that. There are a few more messages that are in the shared lesson that we didn't go through in class. If you're interested in those, you can check out the shared lesson here. So it's just going to be a script of what we went through, and you can step through it one at a time. I will be adding the YouTube video to that at some point later.